Hi, in this playlist we're looking at the Edexcel Foundation Tier Paper 3 from June 2018. This is the third video in the series, and in the previous video we completed to question number 20. So we're going to start again from question number 21. Please do stop the video, have a go at each of the questions and then compare your solutions. Okay, so question number 21. This is a drawing of a trapezium and it's drawn on a centimetre grid. So what they mean by that is that each of these little squares is 1 centimetre across by 1 centimetre high. Okay, and then it says on the grid draw a triangle equal in area. Okay, well, in order to do that we need to know the area first of the trapezium. So I'm actually going to do the calculation at the bottom here and then I'll move the paper up before we actually do the drawing. Okay, so the area of a trapezium, now this is something that is a useful equation. Trapezium, okay, is a useful equation to remember, and it's a half a plus b times h. Okay, now if you're not familiar with that particular formula, then you could find a way really of dividing the trapezium up into maybe triangles, and you could have a triangle down here, so that would be one triangle, and then you could have a small triangle here and then a rectangle in the middle, and then through a little bit of calculation you'd be able to work out the area of the trapezium that way. However, this formula a plus b times h, well, the way it works is this is a, which is 2, this is b, which is 1, 2, 3, 4, 5, 6, 7. Okay, so b would be 7, and then h would be the height, which is 4. Okay, so I can actually plug that straight into the formula, and that's going to give you a half. A, as I mentioned before, was 2, and b is 7, and h is 4. And when I calculate that through, I'm going to get 18. So the area of the trapezium is 18. So if I want to make an area of a triangle which is exactly the same, okay, what I can do is I can use the triangle formula, which is area equals a half base times height, and then I can figure out what height I need my new triangle to be. Okay, and the way I'm going to do that is I'm going to say, well, the area needs to be the same, so it needs to be 18. That equals a half. Now the base of my new triangle, just because I think it's easier, I'm actually going to make it 6. Okay, because if I make it 6, then it does make my calculation to work out the height much easier, because I get 18 equals a half times 6 times the height, which I might count as, say, 6h. Okay, so a half times 6h is 3h. Okay, if I then divide through by 3, I get the height of my new triangle to also be 6. So really all I'm doing is I'm drawing effectively an isosceles triangle on this particular grid, where I've got a base of 6, which is what I created, 1, 2, 3, 4, 5, 6 in my formula. I made that base of 6. Okay, I just figured it'd be a good number to use because I knew it was a multiple of 18. Okay, or rather a factor of 18. So I've got now my base of 6, and then I'm going to then have my height to be 6 as well. So 1, 2, 3, 4, 5, 6. Okay, and then if I use my ruler, I can then just draw those lines together to make that triangle look like a proper triangle. Okay, but nice and straight lines. Okay, hope that's okay for you. You could do it maybe a slightly different way, have a right angle triangle or something like that, but essentially it kind of works for me to do it like that. It's absolutely no problem, providing the areas are the same. Okay, so let's look at question number 22. We've got a probability tree diagram. Okay, in that we're being asked to write down 2 things that are wrong. Well, the first thing that's wrong is actually this number. Okay, now the reason it's wrong is because this number and this number added together need to make 1. Because when he rolls the dice, it's either going to land on a 4 or it's not going to land on a 4, but it's certainly going to land on something. So therefore it should be 0.35. So the actual calculation itself should be 0.35. So I would put in here not land on 4 should be 0.35 as it needs to add to 1. Okay, or you might use a slightly better sentence than mine, but hopefully it'll give you some idea, and I'm sure your handwriting is an awful lot better than mine as well. Okay, so point 2 with that is we're actually looking back at the diagram itself, and you can see hopefully that this is the wrong way round, okay, because landing on a 4 is still going to be 0.65 because he's going to be rolling the dice again. Okay, so this should be 0.65, and not landing on a 4, that should be 0.35. Okay, so you need to put some sort of sentence that say, I don't know, the second throw, so second throw, just wrong way round is absolutely fine. Wrong way around. Okay. You might want to just elaborate on that a little bit, but providing you've circled it on the diagram, I'm sure the examiner will be able to pick out what it is you're aiming to explain. Okay, let's move on then to question number 23. Question number 23, we're really crossing into kind of grade 5 type territory from here on in, really. And this is where, again, you do need to know a formula, and this particular one is using the formula SohCahToa. Okay, so I'm going to write that down for you, but firstly we're being asked to work out the angle. I'm going to call it just x. Okay, well, opposite to x is this line, so I'm going to write that down as opposite. And on a triangle, the longest line is the hypotenuse, which is this line along here, and then the one that's left is the adjacent. Okay, if you're not sure about any of this, there is a playlist on the channel that talks about SohCahToa, and there's quite a number of videos that you'll be able to have a look at and try for yourself. Okay, now what I'm going to do, I need to work out angle x, but I know the adjacent and the hypotenuse, so I'm going to use this ratio here. Okay, so what I'm going to say is the cosine of x is equal to the adjacent divided by the hypotenuse. Okay, if I plug those numbers in, I get that's equal to 7 adjacent divided by 11. Now, bearing in mind, this is the cosine that we're working out, and we're being asked to actually work out the angle. So if you have a look on your calculator, you'll see just above the cosine key, there is, it's usually accessed using shift cos, something like that. Unfortunately, I haven't got a calculator to hand to show you, but hopefully you'll be able to find it, that you need to type into your calculator cos minus 1, 7 over 11 equals. And when you do that, you should get an answer of 50.47. Okay, well, to 1 decimal place, as it asks in the question, that's going to give you an answer of 50.5 degrees. Okay, hopefully that's all right for you. So let's have a look then at part B of the question, and it says length of side AB is reduced by 1, length of side BC is still 7. Okay, will the value of cosine ABC increase or decrease? Okay, well, at the moment, the value of the cosine, as we've just put in, has been 7 over 11. So if I now draw another sketch just to kind of visualize what's going on with these numbers, I've then got this sort of thing. Okay, so the length of side AB is now actually 10 rather than 11 as it was on the original sketch. And the length of side BC remains the same, which is 7. So basically, the cosine now is going to be 7 over 10. Okay, so it's going to increase because 7 over 10, which is the cosine, is greater than 7 out of 11. So if you have a pizza and you cut it into 10 pieces, then 7 out of the 10 pieces is slightly more than if you cut it into 11 pieces and you eat 7 of them. Okay, so the actual cosine itself is going to be slightly increased. Okay, hopefully that's okay for you. Let's move on then to question number 24, where we're dealing with probability, and it's probability in a chart. Okay, so again, a little bit tricky because we are moving into sort of higher level questions here, but hopefully you'll be able to follow this through fairly well. Okay, so some counters in a bag. They're either red, white, blue or yellow. That's fine. Okay, now the bit we're interested in is this. There's 18 blue counters in the bag, and that's a probability of 0.45. So what it means is that 0.45 of the total, if you like, 45% of the total amount of counters is going to equal 18. All right. Well, just to put that into kind of a bit more of an algebraic form, I could write that as 0.45 t equals 18. If I then divide through by 0.45, I get t, which remember is total, is equal to 40. So what I know now is that there are 40 total amount of counters in the bag. Okay. Right. So we know that the blue ones, we've got 18 of them, okay, because it told us that. And we know also that the yellow ones are going to be 0.25. In other words, a quarter of the total amount of counters. So a quarter of 40 is going to be 10. All right. So we're getting a little bit closer to this because now what we can say is that actually we've accounted for 28 of the total of 40 counters. All right. Then it also tells us that there's twice as many red as there are white. Okay. The probability that Bob takes a counter that is red is twice the probability that the counter will be white. Okay, so what I'm going to say is, okay, that's fine. In that case, if the probability of taking a white is x, then the probability of taking a red is going to be 2 lots of x. Okay, so we're now in a position where actually we can put all of this together in some sort of formula or equation to be able to work out the red and the white counters, because we can say 2x plus x, which is red, white, plus the 18 blue, plus the 10 yellow must equal 40. Okay, if we tidy that up a little bit, I'm going to get 3x plus 28 equals 40. I'm going to minus 28 from both sides, so I'm going to get 3x equals 12. If I then divide through by x, I get x equals 4. And that's a great bit of information, because if I know that x equals 4, what it tells me is that there must be 4 white counters, and because there's double the amount of red counters, there must be 8 of them. So actually, in a very long sort of answer to this particular question, we can say that the number of red counters is 8. Okay, that are red. Okay, hope that's okay for you. All right, so let's move on then to the second part of the question, and it says a marble is going to be taken at random from a box of marbles. Okay, the probability the marble will be silver is 0.5, in other words 50%. Okay, there must be an even number of marbles in the box. Explain why. Well, the reason that there must be an even number in the box, the probability is half, is because you can't halve an odd number. So there has to be an even number in order to get a half of it. Okay, so if there's 12 of them, then half of them would be, let's say, 6. Okay, or if there's 18 of them, half of them would be 9. But if there's 25 of them, you can't get half of that number. Okay, now it's kind of difficult to sort of articulate that, or to at least to write it down. So I would put something like, if the probability is a half, there must be an even number as you can't have an odd number. Okay, and then maybe I might write down some examples or something just to give the examiner confidence that I know what I'm talking about when I write those sorts of sentences. Okay, let's move on to question number 25. So we're motoring. Please do stop this video, have a go at this particular question, and then compare your solution. There are about 28 questions in this particular paper, so I'm going to hopefully try and finish the whole paper for you in this video, so we do need to push on a little bit. All right, so I've got a fraction, and that's equal to 2x minus 5. So in order to get rid of that fraction, what I need to do is multiply both sides by 2. Okay, because if I multiply this divide by 2, I just lose it. Okay, and it means then that on the left hand side I get 5 minus x. On the right hand side I get 2 times 2x minus 7. Okay, hopefully that's clear for you. Again, if you do go to the channel, there are some playlists on solving linear equations, which is this kind of topic. All right, so let's just get rid of those brackets. I'm going to leave 5 minus x as it is, and I've got 4x minus 14. Okay, now this is a little bit tricky because the instinct always is to put the x's on the left hand side, but actually on this particular case, if you put them on the right hand side, it's going to make the calculation a little bit easier because I've got a minus x here. Well, if I add x to both sides, it's going to be 5x, which is great. Or if I took 4x away from this side, it would be minus 5x over there, and I don't really want that. I want to try to keep away from negative numbers or negative expressions if I can. Okay, so I'm going to plus x to both sides. That has the effect of losing that, and it means I get left with just 5. On the right hand side, I get 4x plus x, which is going to be 5x minus 14. Okay, now I need to get rid of that minus 14, so I'm going to add 14 to both sides. Okay, and that has the effect of getting rid of that. And on the right hand side I get 5x, on the left hand side I get 19. Okay, so 5 lots of x are 19, so if I want to find one lot of x, I'm going to divide through by 5. Okay, and I would have x. Now I could write 19 divided by 5, but it's just much neater at this sort of level if you write it as a fraction. Remember, it means exactly the same. So x is 19 over 5. If you want to change that to a mixed number, perfectly fine, you could. That would be the same as 3 4/5. Okay, if you prefer, it's absolutely fine. Okay, let's move on then to question number 26, and we're talking about a pentagon. Okay, in a pentagon, we need to work out the size of angle BCD. So in other words, this angle. Okay, and we're told that this angle is double this angle. Okay, so what I'm going to do is I'm actually going to call this angle x and this angle 2x. All right, and then we're being asked to work out the size of those angles, or the size of the 2x angle. Okay, well, one of the things that can help us here is to know that the angles in a pentagon add up to 540 degrees. Okay, so I know that all angles in a pentagon add to 540 degrees. Okay, now you either kind of know that or you work it out, and it's just entirely up to you. Now the way I would work it out, there are formulas you can use, but if you can imagine, you've got this shape, okay, and it looks like something like that. Okay, and if I pick a point on this shape, this is this point here, I can actually work out that actually within this shape there are 1, 2, 3 triangles. Okay, now each of those triangles has internal angles of 180 degrees. So therefore I can say that 180 degrees times 3 equals 540. So all of these angles all added together will equal 540 degrees. Now I do appreciate not everybody will have come across that sort of thing before, but it's something to be aware of. As I say, there is also a formula that you could use as well. But either way, it's important that you kind of know this number. Because what we can say then, if we go back to the diagram, if we add all of these angles together, and they equal 540, we can write an equation that will allow us to find out the value of x. Okay, so let's do that. So I'm going to say 115, which is my first angle, plus 125 plus x plus 2x plus 90 degrees equals 540. And then really it's just a case of tidying that up. And what I end up with is that I've got 330 plus 3x equals 540. That 330 is that one added to that one added to that one. Okay, I'm going to minus 330 from both sides. Now, the reason I'm doing that is that it means I get 3x equals 210. Then I'm going to divide by 3, again both sides, because if I do that I get just x, which is what I want, and that means that x is 70 degrees. Okay, hopefully you followed that all right. So what it means then is that if x is 70 degrees, then BCD, which is this angle right at the very top here they're asking us to work out, is 2x. So therefore BCD equals 2 lots of x, which is 140 degrees, and that would answer this particular question. Okay, right, let's move on then to question number 27. We're 22 minutes into the video. Okay, so I'm going to try to keep this under half an hour if I possibly can. Okay, we've only got 2 questions to go, so hopefully we'll just about make it. The main issue with this question is that both triangles are similar. Okay, what that means is that the angles, these angles are the same, okay, but the actual lengths of the sides are different, okay, and actually if we look at it, they are 1.5 times bigger on this triangle than they are on this triangle, because if you plug this into a calculator, what you'll figure out is that that is times 1.5, okay? So if you did 12.6 divided by 8.4, what you're going to get is 1.5. In other words, if I multiply 8.4 by 1.5, I get 12.6. So in other words, the sides of this triangle, the second triangle, are 1.5 times bigger. So if I want to work out DF, and I know AC, I just multiply that by 1.5. Okay, so DF equals AC times 1.5, and if I plug 6.4 times 1.5, I'm going to get an answer of 9.6. So DF equals 9.6 centimetres, and that would answer that particular question. Okay, and we can use the same idea of working out the length CB, but in this particular case, we've got to divide. So what we're saying is that this is 1.5 times smaller than this. Okay, so this time we're going to divide by 1.5. Okay, so if I just pull the sheet up a little bit, I've got CB equals 15 divided by 1.5, and 15 divided by 1.5 is equal to 10. So actually CB is equal to 10 centimetres, and that would answer that particular question. Okay, so we're very close to the end now. Please do stop the video. Even at this point, please do stop the video. Have a go at question number 28, which is the final question, and then compare your solution. Okay, so this is really where algebra does kind of come into its own. It's slightly tricky because we've got this square root to deal with. So in order to deal with a square root, we need to kind of get rid of it. And the way we're going to do that is we're going to square both sides. Okay, so I've started off with t equals root g plus 6 over 2. Okay, I'm going to make g the formula. Well, the first thing I ought to do, get rid of this square root. So I'm going to put it in brackets and square it. Okay, so the effect of that is that the square root and the square then disappear, and I end up on the right hand side with g plus 6 over 2, and on the left hand side I end up with t squared. Okay, so now I've got to deal with this fraction, g plus 6 over 2. I've got to deal with that too. So to deal with that too, I'm going to multiply both sides by 2, because if I multiply something that's divided by, I lose those and I get g plus 6. On this side I've got 2t squared. Okay, hopefully you're following this. Okay, the final bit of this jigsaw is I've got to get rid of this plus 6 by minusing 6. Okay, again that goes and I get g, which is brilliant because it's what I'm looking for, and on the left hand side I write that as 2t squared minus g. Minus 6. Okay, minus 6. Okay, so the answers to this particular question will be g equals 2t squared minus 6, and that would finish that question. Okay, I think the difficulty with these sorts of questions is that there is always, as I mentioned previously, a temptation to put the g on the left hand side and do some kind of mental gymnastics while you're actually doing this. But if you keep it on the right hand side, it allows you to concentrate and get that nice method showing the examiner that you understand how these things work. Okay, I hope that's been useful for you. That's 28 minutes into the video. We're going to complete everything there. Please do add a comment below if you're not sure about anything. I'll always aim to come back to you. Have a look at the site itself, and there are other examples of other foundation papers on the playlists. And I'll look forward to seeing you inside the next video.